All right, this is a video on the scientific notation. This is a math function that you got to be pretty familiar with in chemistry, because in chemistry we work with really, really big numbers oftentimes. Well, I should say we work with really long numbers. Those numbers can be very, very small too, but yeah, really, really long numbers. And what scientific notation allows you to do is make those very long numbers into shorter, more manageable, and correctly rounded numbers, which the rounding part we're going to talk about a little bit later, but it's really useful for this kind of thing. So let's just give an example here. The wavelength of ultraviolet light, this is a topic that we'll probably study later in the course, but it's just a good example of a very, very long but small number, right? And this number is a pain. We have 1, 2, 3, 4, 5, 6. We have 6 zeros out front of our first real number, and that's not a very manageable number. And so what we want to do is trim that puppy down into what we call standard scientific notation, and that just means that we move the decimal place until it is right next to the first real number. Okay, so the way we do this is to take the decimal point and you just bounce it from 0 to 0 until it ends up in the proper spot. So we want to have a number and then the decimal point and then possibly some other numbers, but the decimal point needs to go on the right side of the number. And then you would count the number of places that you've moved the decimal point. So we've moved it 1, 2, 3, 4, 5, 6, 7 places to put it into the right spot. All right, so that number then ends up looking like this: 1.0 times 10 to the negative 7th power. And the negative 7, anytime you have a negative exponent up here, this means that you're dealing with a very, very small number. It means that the decimal place has had to come a long way to the right to get where it's going to be, okay? Here's another example. This is a good one. In 30 grams of iron, which is an elemental substance we're going to become very familiar with, in just 30 grams, and by the way, that's not very much iron, by the way. That's like you know, the size of your little finger or something like that, or maybe even smaller. Anyway, in 30 grams of iron, there are this many atoms. Holy moly, I don't even know what this number really, I don't know even how to call this number, but it's a huge number and it's just not manageable at all. And so we want to put a number like this into standard scientific notation. And this time, whereas in our first example we moved the decimal place to the right to get it where we want it to be, this time we got to move the decimal place to the left. So, you know, this number does not have a decimal point included in it, but if you were forced to say where there should be one, it'd probably be right here at the end of the number, right? And so we want to do the same thing we did before. We've just bounced this along this line of zeros until we finally hit our desired place to be, and that is where we would have one number and then the decimal point. So we're eventually trying to get to right there, and it's pretty easy. You just bounce 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24 places. So we've moved the decimal place 24 places to put this number into standard scientific notation, and that means that it looks like this. So I've not included a bunch of these other numbers, but because I've rounded, but if we were just going into standard scientific notation, it might look like this: 3.233661594 times 10 to the 24th power. Now, that's oftentimes not going to be a type of number that you would report as an answer for anything. That's just a pretty unmanageable number by itself. So anyway, that's where rounding comes into play, and we'll talk more about that here in a bit. The last thing to remember here is that the positive exponent that indicates a very, very big number, okay? So just as a rule of thumb, when you see a negative exponent, you're thinking very small, and a positive exponent is a very big number, okay? So that is scientific notation. Hope that helps.